Let's get this running. Okay, can you see the screen okay and hear us okay?
Yep, I can see the screen and sound is okay. Everything is good. Thank you.
Perfect. Well, thank you everybody for joining us today. Today we're going to be going into the Power Query formula language. My name is Matt Mason and I'm a PM on the Power Query team. And I'm here with Theresa Palmer, who's also a PM on the team. And yeah, today we're basically going to go into, we'll do a quick demo of Power Query itself and then we'll focus on the language. So we have about 60 minutes today. There's a lot of stuff to cover, so we are going to go through things pretty quickly and we'll save most of the questions for the end. If you have questions throughout, feel free to ask questions through the meeting or in the chat window, and we'll get to them. But we're gonna try to leave some time at the very end of the talk to go into to answer any remaining stuff. So today we'll start with a quick overview of Power Query and why you'd use the underlying Power Query formula language, also known as M. We'll talk a bit about the language structure itself. A lot of the content in this deck you'll use for reference. A lot of the stuff you're not going to grasp. It's very hard to pick up a new programming language in just 60 minutes, but we're sort of going to give you enough details and enough information to make you dangerous and point you in the right direction so where you can go from there. And then the last part of the demo will hopefully have time to go into a bunch of different examples of when you'd use the Power Query formula language. So a question we commonly get is about Power Query is where it fits in, right? And part of this Power BI thing that Microsoft has launched, a lot of different Power products. So this slide is basically meant to say that Power Query is usually your starting point. Power Query is your way to discover data, grab data, shape the data, apply filters, and bring it into Excel, so then you can move on to the other stages of BI, like Power Pivot to build your data models, define your measures, your hierarchies, your KPIs, and Power View to actually visualize your data, and Power Map if you're working with geospatial data and you want to basically make these nice, pretty worldwide videos and zooming around on different data points. So Power Query, I like to always say, is the starting point. And so let me just jump straight into a Power Query demo. So let me watch. So Power Query is an add-in for Excel. Hopefully most of you have seen Power Query before. We weren't going to go into too much detail of kind of basics about it. But just in case, I'll give a quick reminder. So Power Query add-in for Excel, separate download for Office 2013 and Office 2010. You install it and you'll get a Power Query ribbon. You'll see it looks a lot like the Excel data tab. There's different data sources here. One of the key differences is that there's this search capability as well. This is a Power Query functionality that gets further enhanced if you have a Power BI license, where it lets you search for existing data sets. And it'll give you data that you can easily import into an Excel worksheet. So for example, I click on search and I search for something like GDP, and I can see different data sets that have been published within my organization, or as well as public data sets. So I can see data from Wikipedia, I can see data from the World Bank, and a number of different public data sets out there. So that's the whole discover aspect of Power Query. And I can also connect to different data sources. And Power Query connects to a large number of data sources, and we're always adding more. So there's traditional file, there's web, there's a number of different databases and other data sources as well. So SharePoint, Azure Marketplace, different Azure different Azure sources, even Active Directory. And so I'm just going to do a quick connection to a traditional thing you'd see in Excel. I'm going to connect to a local database, a local SQL Server database. I type in my connection name, and kind of zooms in and shows me my different databases on my server. I can select multiple multiple tables here. I'm going to select my product category and my subcategory. Oh, and did I just lose presenter? Yeah, I lost presenter. Let's see here. Reza, are you still there?
Yes, I think you just... okay, let me just make you a prisoner again.
Did you reset? Yeah, please reset me to prisoner.
Okay, I made you prisoner. You should be able to prison now. Can you see anything?
Not yet.
Okay.
Okay, maybe that broke on my side. You can't see my screen yet.
Okay, let me just show my screen for a second and then make you a prisoner.
Okay.
Okay, it's showing the application.
Maybe I should reconnect.
Yeah, I think you should reconnect again to...
Okay, I'll be here. Let me try that.
Yeah, okay. Matt will be with us shortly. If you have any questions in the meantime, you can ask your questions.
I'm back in.
Okay.
You're making me a prisoner.
Yep, you are a prisoner now.
Okay, so let's do this again. Sorry about that, guys.
Okay, cool.
You can see my screen again? Okay. Yep. So I had just, in Power Query, I did connect to a database. It brings up this nice navigator where it lists my databases. I'm going to select two tables here. So I'm selecting the product category and product subcategory. I said don't load them. I unchecked this box here because I want to actually edit those queries before I get any data. So let me select product subcategory. I can double click. It's going to bring up the query editor. So this is one of the nice things about Power Query. I get a nice sample view of my data. We have a nice ribbon at the top with different actions you can perform on your data, so to do your different filtering and shaping stuff. The main reason why I'm showing this as an intro to the language is because you're going to find, or at least I find, the easiest way to work with M is to do a mix of doing things visually in the UI, because you're more productive that way, and then switching over to the language whenever I need to. You can actually do all this stuff directly in the language, but I find using the UI to at least get started really helps. So here I have my data, and I can grab some of the columns that I want here and remove my other columns. And I'm going to then, whoops, that's not what I wanted to do. I want to do it the other way. So I grab my columns like this, and I say remove other columns. And now I'm going to click this merge button and merge with my other query that I have already selected. And so again, Power Query helps you in the UI as much as it can. So it asks me to select the columns. It shows down at the bottom that that there's a match on those two columns. If I selected invalid columns, it gives me a warning saying the data types aren't the same. So it tries to be as helpful as possible to all these nice UI gestures and stuff. One of the advantages of using Power Query. Select OK. Now I have a new column that I can then further expand. Right, so I'm basically doing a join here between the two tables. I expand, do some more transformation, and I end up with a query that's in a shape that I want. I can then import that into Excel. So after doing all those operations, I want to call out a couple of key things. So over on the right-hand side of the designer, we have this applied steps box. And that basically shows you step-by-step all those different transformations that I did in the UI. Each action introduced a new step. I can actually click between the steps and see my previous state. And so I see how the data is flowing from one step to another. You can even click on these nice little builder buttons, and that will bring up those UIs that I use to create those things. If I go onto the advanced tab, or sorry, on the view button, the view ribbon, There's an option here to enable and disable this formula bar like you see in Excel. And also an advanced editor. If I click the advanced editor, I can see the M code behind that query that I just built up. You also notice that the M code is laid out in steps as well, connecting to the source, selecting a certain database, selecting my query, and selecting columns. And we'll go into how to build those things and how to actually read the M code throughout this talk. Key thing to call out there is the steps you see in the UI almost completely matches the steps that you see in your query like this. So I will quickly show something else you can do. As you're playing around with M, you'll find this very useful. If I go to other data sources, I can actually start with a blank query as well. Blank query gives me no data, and I have this formula bar that I can start typing formulas into. So if I zoom like this, so I can do 1 plus 1. Type 1 plus 1, that actually becomes a literal 1 plus 1 because I didn't include the magic formula button. If I say equals, now I have 2. And I can
sorry, Matt. I see again a window that say you're the presenter. Are you still presenting?
Yeah. I'm still presenting, and it looks like our second window is showing it as sharing okay. So
okay. Good.
Okay. So I can do some, mathematical expressions like that. Right? 2 times 8, 16. I can do some simple stuff. You're going to see in M, there's a lot of, M is very functional, so there's a lot of built-in library functions. And if I type in the name of a function, I get the nice help here that shows me my different arguments and provides some examples. And the UI also gives me an invoke button. Clicking invoke brings up basically a function caller that lists all the different parameters for that function. And it's a nice helper. So there it wants a start date, the number of days to use, and I'm going to say my step is 1. And it calls a function and gives me a nice list of values. And so you can go from really simple stuff like that to much more complicated examples, and we will show that for the rest of the talk. So it's a quick whirlwind tour of Power Query. Quick overview. Let's go back to the slide deck. Start presenting this again. Quick summary. So Power Query is a better way to get data into Excel. It's pretty much a lightweight ETL tool. I wouldn't call it a full-fledged ETL tool. There's no control flow concepts. There's no advanced logging or error handling, anything like that. But it's an ETL language targeted for self-service for self-service BI. There's some search and sharing features in there that let you consume data from public data sets. Also, with Power BI, you get to share and find data within your organization. And underneath all of Power Query is this powerful transformation language called M. And we'll go into that next. So, Theresa, over to start talking about the language informally known as M.
Great. So yeah, we included the fact that it's informally known as M because it has been referred to that in certain documentation and blog posts and that sort of thing, but it's not the official name. Typically, we call it the Power Query formula language. So a couple things to note about the formula language. We are targeting the information worker, as Matt said. There's also some data analysts target there as well. We're looking at the intermediate to advanced Excel users. So the users that can write Excel formulas and actually do typically write Excel formulas. So for that audience, we should make sure that the language is familiar and easy to remember. We need to make sure that it's easy to write and read. And of course that it's a superset of the Excel formula language. So that's something we're actively working on, making sure that things you can do in Excel you can do through Power Query as well. We also wanted to make sure it was close to concepts in DAX where appropriate. There's some overlap that you'll see. And of course, we still wanted to bake in those powerful capabilities for the advanced user when they want them.
One thing I sort of call out, we get asked often why we introduced yet another language. And once you start using Power Query, you'll see it's really, the language itself is really meant for data transformation, and no other language really maps as close in concept. Once you start using it, you find how easy it is to actually use. It all makes sense.
Yeah, so comparing some of the other languages that you know of. So syntax for a simple query. Of course, you know, we see SQL. This is something that's pretty straightforward, just doing a basic inner join. Comparing it to some other languages, C#, you can see the same action just in the different syntax. And then finally, Power Query, you'll see some similar objects within all the different syntax, but you can see that in Power Query, we formulate them by individual steps, and you can see each step corresponds to one or more functions. Speaking of functions, we do have a wide variety of library functions. So some ways that we typically break them up, we have data access functions, so this is how you connect to all those sources Matt was talking about at the beginning. We also have a ton of different transformation functions, so this is where you go, you know, to text, or you do joins, or you sort, or you select, or rename. Unpivot is one of our really useful transformation functions as well. And then we have another set of functions that kind of fall into the other bucket. We have a whole set of binary functions, which are pretty interesting. We might get to if we have some time today, and some other expressions as well. We do have a full library spec that's available online in our Power Query online help. This link will also take you directly to the download page as well. Great, I'll pass it off to Matt.
Okay, so like I showed in the demo, the language or the way to look at M is that it flows from one step to another. I know when I was first learning M, this took me a while to get used to. And I like to say it flows from one step to another, except when it doesn't, because there's times that you can skip steps or not evaluate steps at all. So in this simple query here, that first line is calling web.page and web.contents. Those are two functions. Basically, I'm going to go out to that web URL and bring back the data. The second line takes the result of the first, so that source line we're referencing on the second line, and then indexing in to grab the data. And then that creates a table, and we then assign that to web table. And we use that web table step in the following line. We call the function table.rename columns. We pass in the table from the previous step, and then pass in more arguments to actually rename the columns within that table. All right, so the language itself really does flow. So you read it from step to step to step. Another example, like we have below, this is an example where steps don't necessarily flow from one step to another. First line is selecting the source data, source database. The second one is selecting a specific table from that, the dim product category, and assigning that to a variable or step called dim cat. The next step is selecting another, right, we're reusing that first source step. We're selecting another table from the database for dim subcategory. And then we select the third one, dim customer. So now we have three different tables, dim cat, dim subcat, dim customer. And then we are that final nested join call is joining two of those columns together. So we're calling a function and then passing in two previous steps. The outer section of that M, the let, which basically starts an M expression, and then the in, you can think of the in as a return value. So in this case, we're saying in joined. And when this M program or this M query gets evaluated, it would actually, because dim customer is never actually referenced, it would be stripped out of the end evaluation here. I'll show some examples there. One thing to call out, one of the most powerful things about Power Query itself is what we call query folding. And this means that we will look at the end-to-end M program and figure out what steps can be pushed back to the source system. So if I was building a query where, like I did in my previous demo, where I first select different columns that I want to keep out of my original data set, in this case I'm renaming one of those columns, and then I add a filter to my query, the M program or the M query would look something like this, where I am collecting the source, and you can see where it pointed out on the removed other columns step is where I'm actually selecting the columns that I want. On the rename column step is where I'm performing that rename, and my filter row step is where I apply a filter where I say each product key is less than 10. Right, so I did all those steps in the UI. This is what my M program looks like, but when it gets evaluated at runtime, the M engine doesn't actually run it step by step. It will look at this whole thing and figure out the most efficient way to evaluate it. So in this case, we have that original query. We have those three main steps, the removing columns, renaming columns, and then applying a filter. That would actually get folded into a single T-SQL statement that runs against that source database. Right? So even though you're writing the language in a step-by-step flowing thing, the M language itself isn't necessarily going to execute it in that order. Right? So Power Query is always going to try to fold all that work back to the server wherever it can. Another thing to call out is when Power Query is working against a data source that doesn't support folding. So for example, if you're working with a flat file, right, a CSV file, there's no engine to fold to. Power Query will just do all the work in memory. The nice thing about Power Query is that there's no cliffs. It means that no matter what data source you're working with, it's going to provide the same set of features and transformations. Anything that can't be pushed back to the source, Power Query will just do directly in memory. So talk about what gets folded. So we actually fold lots of different things. Think of it as filters, joins, group by statements, pivots, unpivots, different calculations. But what we actually fold depends on the data source. So we fold most stuff to relational sources like SQL, Oracle. We also can fold to OData and Active Directory and Exchange. There's some of our data sources will support limited folding, like on filters and things like that. And like I said, whenever something can't be folded to the source, Power Query will just do it all in memory. Whether or not something gets folded is basically controlled by internal Power Query logic. Power Query will determine when it's most efficient to fold and what should be pushed. If you're using a thing called native database query, which Tessa will talk about next, that actually disables folding. So native database query seems like this great feature that lets you write in a SQL statement in Power Query, but there's downsides to using it. And also data source privacy levels, which I think we'll touch on later in this talk.
Great. So speaking of native database queries, so this is something that really just lets you provide a SQL query that will be executed directly against the source. The way that you provide it is when you connect to it. So when you go from database, there'll be an advanced option that lets you provide your SQL statement. So we chose to add this because there are some times when the generated Power Queries aren't sufficient. Either they're missing certain options, some parameters, or you guys can actually just write SQL better than we can. So there's some specific requirements, optimizations, like I said, that Power Query doesn't support, and you can leverage the SQL statement for. The other big reason that we added it is because we know that our users have existing queries that they're using. Either this is something that they've written or something they've been given to by their admin, and they don't want to have to or figure out how to translate it into M. In fact, they don't really know what the query is doing. They just know that it gives them the data that they want. So this was a way to let them leverage those queries as well. And as Matt touched on quickly, there are some important caveats to this functionality. So because you can put any type of query in that statement, the functions on top of the queries aren't going to be folded back to the source. So we don't do any sort of analysis to kind of figure out if the statement you provided is something we understand and we can fold on top of. It really just breaks the folding pipeline at that point. The other thing is that the query isn't parsed before sending it to the source. So if you want to drop tables or do whatever you like, that'll go right through to the source. And the other important caveat is that just based on our functional language and the way that things are evaluated, we can't guarantee how often it's executed. So keep that in mind. It should really be only for read statements. So those are the important caveats to keep in mind when you leverage that functionality. It is really useful for certain capabilities, but it can also trip up some users as well. Great, so now we're going to go into writing some M queries. The first one we're actually going to do really quickly is going to be the one that Matt touched on really quickly, so I can just do it here. So pretty much what we're going to do is we're going to give an example on how you can leverage the UI to get you to a certain starting point, and then after that you can build your own or write your own M to make it a little bit more optimal. So here I'm just really quickly going to connect to Northwind, and we're going to bring in just customers and orders. Okay, I'm going to change my settings and load it to the worksheet. So pretty much here, just doing what you would typically do, connect to a data source. It's all pretty straightforward so far. So what I'm going to do is I'm going to edit this customer's query. Great. And at this point, I'm going to merge. So we know that customers and orders are related. And I'll just do a really basic merge. So this is the UI. Information worker doesn't need to understand what a join is. We have visual tools, helps you connect, as Matt showed before. So at this point, they've done, we've created a new column, and expanding this will do the merge. While we're over here, you might see that we actually have some of these other nested columns here as well. One of the things Power Query does when foreign key relationships are available, we do nest them into the column for you so that you can access them without having to do a merge yourself. So instead of doing the merge, I actually could have come over to this orders column and expanded it and would have done the exact same thing. So let's take a look at the M that's been generated. As Matt said, this is sort of our advanced view. Let me zoom in here. Great, so you can see here I connected to the data source. In the first source step, I found my database, and then I found my table, DBO customers. And so the important thing here is that in the merge step, you can see it references orders table, which is actually a query that is in my workbook. So it's not from this specific step. It's another query in my workbook. So if at this point I wanted to also add order details, what I could do is choose to add order, to connect to order details in this specific query instead of writing it again myself. So let me highlight this. So I'm going to do exactly, so I've already connected to the database. Instead of connecting to customers, here I'm going to replace it with order details. So just showing you a quick trick. Instead of showing the merge step as our last table, I'm going to use our order details as our last table. And this is, as Matt said, it actually won't then execute the merge, but it'll show, oh good. I hit a combination issue. So let me bring this back up. Let's go back into what we were doing. So one of the things, to touch on the combination issue quickly, one of the things, the feature in Power Query is our security feature, which we call the firewall internally. And so it helps ensure in the folding case that you're not sending data outside of your organization when you don't want to. You'll also find as you start doing more advanced steps that you might hit something that requires you to rebuild your query in this case.
Yeah, as a new Power Query user, I hit this often. I was trying to figure out what it actually is. And so the way to think about it is it's a way of preventing you from accidentally sending data to another data source. Like for example, if you're merging two things together, or two different data sources together, you're merging, say, your corporate data with a public web data service. Right? You don't want to send your list of customers out to that public data source as part of that join. So the query firewall lets you specify privacy levels and prevent that sort of folding from happening.
Yeah, so what we can do here instead of, so what I'm going to do, back to the example again, what I'm going to do instead of connecting to the other table, I'm going to access orders directly in here as well. So let me just, I typed a couple extra things while Matt was talking, sorry about that. So pretty much I'm rebuilding exactly what we had done through the UI, but instead of accessing the other query, we're going to do it in the same step. So here we go. Instead of the query orders, we're going to use this step DBO underscore orders. So pretty much it's the same. We're merging on the same thing. The only difference is I've referenced the query in this line, the step in this line, the table in this line, instead of referencing a separate query. So you can see here, as I zoom out and hit done, it's going to give us the same join that it had done before. You can see here, I have the same new column, and I can expand the same way. So that quick trick, instead of having you import separate things, you can choose to access and merge multiple things in one line. So again, I can add order details and do another merge step, and I've accessed and combined 3 tables in one query as opposed to having sort of a table per query idea. So let's hop back over to the presentation. Great.
Okay. What's up?
So we're going to touch really quickly on the type system. So we do have a small set of built-in types. We have this notion of any, which is really
Object.
Yeah, any, exactly, any type. It's kind of the catch-all bucket. And so we also have nulls, logical, number, text, binary, and then some more interesting ones like time, date time zone. We have a bunch around this, as you can see. Also some complex types. So we have lists, records, tables, and functions, and you can also define your own types as well. So you won't see here's some examples below where the types are referred to. The other thing is when Matt was showing that function text, you'll see that each of the functions also have the types that they require in their functions. But typically as you're writing, you are more keeping the types in mind. You're not necessarily referencing individual types.
Yeah, I think where types come in most handy in M is when you're writing your own functions and defining functions, because then you can specify what's required as a parameter. So it's always good to have an actual type on the parameter, so it's easier to call.
And of course, this won't stop anyone from putting the wrong type in your function, but it will kind of put UI guidelines around it. So the invoke builder that Matt showed quickly will generate better samples and do some basic checking there. The function, the actual language will let you put whatever you want, wherever you want. You'll hit the error message as it's evaluated, but really defining these things up front can also help your users who are going to be using it through the UI. So some examples quickly. So nulls, obvious, logical, numbers, text, date time, all the different date and time types as well. You can see here there's a shorthand around defining them, which I'll get into really quickly after looking at the complex types quickly. So complex types, as I was saying, we have lists, records, and tables. And you'll actually start noticing in the demo just after this how they kind of work together to combine and define each other. Functions, where they take parameters. You see here we have x, y, and an optional parameter as well. And then type, here we're defining our own table type. And the sort of special complex value called binary, and we can get into that a little bit later.
Yeah, and this slide is more for reference. It just shows us the way you create custom types. I've been using M for a couple months now, and I find you don't use types too often. I think record types are the most common thing you'll do, where you'll declare a record with different columns, and maybe lists and creating your own custom functions. But yeah, in day-to-day, most usages, like we'll show in our demos, you typically don't have to worry about the type system.
Yeah, so we'll jump into a quick demo. The nice thing about the type, about understanding these types is really just, as we were saying, when you're invoking your own functions and that sort of thing, to know how to leverage it. Let's just discard that. So I'm just going to go into a blank Power Query screen quickly, and I'm just going to go through a couple of really basic types. So Matt already showed our 1 and our 1+1. So at this point, I'm going to go into lists. So lists have the curly braces and are comma delimited. So you can see here I just built a quick list. There's also some shortcuts around generating lists. So if I want a list from 1 to 10, instead of writing it all out, I can generate it here. Records, as Matt said, are pretty useful, mostly because you'll see how they're a part of a table in a second. So really basic record has square brackets. You can have multiple values in your record as well. Ooh, don't put 2 square brackets, just 1. And then you can start combining these things. So instead of having 1 record, you can have a list of records. And this, what it'll do, you'll see in a second. Great, so square brackets, curly brackets, and now I have a list of nested records. And you can see at this point, I have a convert option to take this to a table, but instead there's another way to do it. You can also choose to go use a function. This is what would happen if I invoked it myself. So we have a function called table from records. And let me get to the end here. So it's a list of records, and it's going to create a table. So you can see I have 2 columns with different values. Now this could get pretty tedious if I wanted to find my whole table, and I have to type out the column name every time I wanted to add a value as well. So another shorthand, which you saw on our slides, and use that for reference as well, as Matt was saying. But we have this notion of pound and then the type. So pound table is one that I use pretty often. And pretty much it's going to be a list of values. So first I start with the column names. And then I'm going to have another list of lists. And every, I specify the row as its own list. 3 and 4.
So that first argument is your column names, and then your second argument is a list of rows, basically.
Yeah, exactly. So there we go. I have the exact same table. And then really quickly, if I wanted to add another line, I can do it here. And that was much easier than having to define it each time. So that's some basic ways to define different types. You'll find as you invoke things that you'll leverage that more often.
Yeah, and like Tessa just said, the main reason to do that is when you're defining your own functions and you want to call a function over a list of data or over a given table of data, you then create a table like this by hand and then invoke as part of a merge.
Exactly, yeah.
Okay. So that was a quick demo on types. Okay, unary functions. This is where it gets slightly more complicated, but this is another important concept that it helps to know in M. So in this case, there's a lot of times where you're going to be calling a function over or performing an operation over a set of rows on your table. Okay, so in this case, I'm calling a function called table.selectRows. So it means I'm going to go through row by row of my table and then select every column where manager is equal to buddy. Right? So it's comparing 2 values within my table. And so the arguments are basically, the first argument is the table, so it's usually the previous step within my table. And then I'm saying that there's a single argument for this, for the function I'm going to call, and that's going to be the row, represented by R here. And then that goes into an expression where I'm comparing manager equal to buddy. Those are both columns within that row. So a lot of the times, the function that you're calling is going to be unary. So it means it has a single argument that goes into it. So there's a shorthand expression called each. And so each means perform this operation on each row. So these 2 statements are syntactically equivalent. We also have another shorthand on that to get rid of the underscore, which was essentially added to make us in line with the DAX syntax that people are familiar with. Basically, all 3 of these expressions are syntactically equivalent. This is basically saying for this table, you pass into table.selectRows, you want to compare each row as manager equals to buddy. So this is one of those M things that, as a new language, I needed to wrap my head around. But you'll find that each function or that each expression is used very often as you're putting things together. Some other special syntactic forms. These ones are less common. This is more advanced stuff, like doing if, then, and else within your M programs. There's the let expression. You're usually doing that in the same way that we've done it, where you do let and then an expression and then in as a return statement. But there's some other stuff you can do there too. There's some error handling where you can say different error cases into basically it's like a throw, and there's a try expression, which is more like a catch. So we included these things here just so you're aware of them. You can look them up within the language spec, for example, on how to actually make use of them. Okay, and now we'll go into some more examples. Yeah, let's switch over. Theresa, do you want? Are there questions?
Yeah, there's a couple questions we can go through really quickly.
Okay.
Thanks, Michael, for trying to save me in my when my demo didn't quite work. But I see one question about the kinds of joins that are allowed. So we do actually support 6 different joins. So we support inner, left outer, right outer, full outer, left anti, and right anti as well.
Yeah, so type in the table.join help function, or yeah, the table.join function, it brings up the help, and you can see the different types of joins that we do there.
Great, and then I see another question about is everything that can be manually written can be displayed graphically? Yeah. Go ahead.
So no, actually, we expose a lot of different things within our ribbon, and I assume that this is what it means. We have a couple of different improvements coming up that will add more stuff to the ribbon, but really you can do a lot within the M language. So everything you do in the language will always be able to be displayed as a table, if that's what you mean. Like you'll be able to see any step of your results in the table, but not everything is exposed through the formula bar. And that's it's an interesting balance to make, because we think that using the language is more of an advanced scenario. Adding too much to the ribbon sort of confuses things and takes away from the the main information worker type scenarios. But yeah, everything you do is always you can always visualize it.
Yeah, you can always visualize it, and we're working to add stuff into the ribbon so that you have to potentially type less and less. So what the goal also is that the functions are useful to just about anybody, but sometimes it's the optional parameters or the different way that you invoke that function that's sort of the advanced side of it. So in many cases you can actually use the UI to generate sort of the initial function signature, and then you can tweak it as is appropriate for your case.
Yeah, I can imagine in the fullness of time, right now we see that it's basically a straight text editor. I can imagine in the fullness of time that this becomes a bit more full-featured with IntelliSense and drop-downs and function parameters and arguments and things like that. Another great thing about Power Query is we basically ship on a monthly cycle, so there's always new things that are being added. I actually had to uninstall and install our latest release build because we have a bunch of new features that are unreleased yet that we're not allowed to show you guys yet.
Yeah. So one more question I saw about a question about when to use Power Query and when to use DAX, or sorry, when to use M and when to use DAX, which is also when to use Power Query and when to use DAX. Matt touched on it briefly. We view Power Query as the get data scenario, and so a lot of the times you use M to shape what the resulting data that you want into the model. So anything that can be folded back to the source, anything that's part of that sort of initial import process is typically done in Power Query, and then your modeling and building up your different measures and KPIs, that can be done in Power Pivot. Now there are some cases where you're connecting to a source that, say, isn't very big, but maybe it's quite slow, and so Power Query trying to fold or trying to do things locally isn't going to be as efficient as if you have loaded it into Power Pivot and then use DAX on top of it. So it really will depend on your scenario and your source, but typically Power Query and M is sort of that import step, and then once you have that data in your final shape, then you can use DAX to further manipulate it when it's in the model.
Yeah, I basically say if you want the data in your data model, then you do the aggregation and stuff in DAX. If you want to filter it out before it even lands in Excel, then you use Power Pivot. And it's not a clear line, but that's one way to think about it.
Great.
So let's go into some demos. We see there's a bunch more questions, but let's get a couple of demos down, and then we'll jump back to the questions at the end.
Yeah. So the first demo I'm going to show is a demo that we've shown before that you might be familiar with.
I think we have it.
We have it
the web
open.
browser. Yeah.
Okay.
show that real fast.
Great. So this is our Box Office Mojo. So pretty much it is a site that has, let's not do 2014 because we're still doing 2014. So this is showing, you know, different up to the top 686 movies in 2013, and they're ranked by domestic gross. So let's copy in one of them, and we'll connect to it in Power Query. Okay, so just paste in the URL. Let's see. So here you can see that I can hover on top of the different ones to find the table that I'm looking for. And you can see that table 1 was that table. So I'll hit edit. And there we go. So a couple clicks and I have that table into Excel as I want. Now one of the interesting things that you'll see actually when we look at the advanced view is that here the page is actually a parameter into the URL. So one of the things we talked about building our own functions, so one of the things we could do is take out this hard-coded value and make it a parameter into our own function. So we're going to do this in a pretty easy way. I'm actually just going to create a new value, page num, and we're just going to add it right into the middle of this parameter. So if I just hit OK now, not much would happen. Actually, I would get an error because I haven't said where that value is going to come from. So this is me defining my own function. I take the value, and it's going to go into this these series of steps that I've listed out before. So I'm going to zoom back out, hit OK, and now you can see I have a function invocation page instead of my result list. So you can see here, if I invoke it, OK, I have to convert it to a value. So this is where we talked about having our own types. So this is going to, instead of just concatenating it, I'm going to go number to text. So leveraging one of the library functions to translate that text into a number. Another way I can do it is I can specify that it has to come in as a number, and then it'll you can specify the value to instead of the text value to. So you can see here then I evoked it, and it works as expected. It gave us that same result.
So if you remove the invoke step and go back and invoke as a different page.
Yeah, let's see what's on page 3.
So really simple way. Now, yeah, just that one line of code basically at the beginning turns your regular query into a function that can be invoked dynamically.
So one of the interesting things here is that you'll see at the end of the page, they have this sort of 3 lines of junk. So one of the things I could do is using one of our M functions, I could, choose to keep the top number of rows. One of the things that so I could choose to keep top 100 rows, say. Great. Zoom back out. And then now that junk will all be gone at the end. But one of the things I noticed, I think I said 680 something. So instead of keeping just the top 100, again, I can use a little bit of, it generated this information for me. But instead of just keeping the top 100, I can use another trick to, we know it's always the last 3 rows. So instead of always being 100, I can reference the table that I wanted, which is right here. It has kind of a funky name, so let me copy it so I don't mess it up. Great, and then I'm going to say that table, the size of that table, -3. So that will always take off the bottom. Perfect, I wrote it correctly, and then you can see here that 300 works. So one of the things that, do we have time to show it today? Pretty much what I could then do is I can invoke it over a full, I could generate a list and say 1 to 4, and then I can invoke this over each list, and I can combine them together. And that's a really easy way to get that full web page into one table, as opposed to having, 6 different queries or something.
Yeah, let's show some of the other demos, and maybe we can get back to this one.
Great. So here I'll remove the invoke. And
just copy and paste from what we have on them.
oh, okay. Yeah, I can do that after. Perfect.
Okay. Do you want to show the removing dynamic rows?
Sure, yeah. So one of the other problems that you can tend to have, let's see if I have this Excel document up, and this one actually came from something on our forums. So they had a file. My example is a text file, or sorry, an Excel file, but it has a bunch of information at the top before it actually gets to the data at the bottom. So you can see here it's just a bunch of junk text. But the interesting thing that I want is this table down here. So back in Power Query, I can choose to import from an Excel file. And let me copy over the actual text. Great, so you can just paste something in directly here. And so same thing, I only have one sheet, one table, so I'll select that one. And you can see here I have all of this junk. Now again, it would have been really easy to just kind of remove the top rows. So I can, remove the top 7 rows instead of doing this processing. But something that's really easy if you know what your a header in your table, or if you know the value that you're looking for. One of the easy things to do is actually use M to define it instead. So let me zoom back out. So what I can do here, I'm going to paste this in. Great. So zooming back in. I've done a couple steps and I'll walk through them quickly. So the first step, I've chosen to look for the row that has text that starts with the value A. So in this case, I know that I want to start with the value that has A in it. So I found that value, and then I'm going to figure out based on another function, table position of, the actual position in the table of that row. So here it's going to tell me the number of that row, and then finally I use the table.skip function to actually provide that position, and we're going to skip the top n rows to get to our final sheet. So let me zoom back out.
Change your end statement.
Yep, great. So without changing this end statement, it would have given us the exact same result as it did before. But we're going to leverage what we just wrote, and we want top remove to be our last step. And let's hit done. And so you can see here it found that A was the top one, and I trimmed it right down to that. So now if that column, if that file changes and we add another couple lines of junk, it'll always trim it down to this one because we didn't hard code the number. We actually find out the number based on the shape of the table. So that's a quick trick to deal with files that have interesting data, but the top sort of junk can change.
If we step through this again, we see here's our original source query. We went down to the filtered rows, and then we got that table.position. So that's basically telling us that that A that we looked for was on row number 7, and then we got rid of all the rows up to that point. Okay, so I'll do one more quick thing, kind of showing leveraging the UI and existing data sources. So one of my favorite things is the Windows Azure Marketplace, also called the Data Market. And if you haven't been there already, definitely check it out. There's a lot of great data sets and great web services that you can leverage on the data market. So for this demo, I'm just going to connect to the data market, and I'll see all the different data sets that I've subscribed to. I'm going to show the Bing Search API. So this is an API that you can subscribe to. There's a free version and there's a paid version. Gives you more queries that you can send to it. This basically lets me send values to Bing Search and get back different results. Right? So we recognize that Windows Azure Marketplace is an OData service, and it's showing these as OData functions. And the good thing about Power Query and OData is that we recognize OData functions just like we would a Power Query function as well. So I'm going to invoke this. So I'll click Edit. This is calling the web function of the Bing Search API. We see it actually comes back just like it would with a Power Query function. And it even has a nice builder for me. So I click Invoke, and I get all the different parameters with examples. I even have drop-downs here, so I could search for, say, search for Microsoft, and I can filter out to different markets. So I just want EN-US, and then, yeah, I can search by location and different things like that. Click OK. That's going to invoke that web service and bring back my different query results. So it's a unique ID for every query result, and here are all the different web pages with descriptions and display URLs that come back as well. So very handy web service that I can call dynamically. If I want to turn this into a function that I can call, I have two options. If I go back to this code, I can reference this function like this, right? If I call it, let me rename this to something nice like Bing search function, and change that name here as well. Close that. So now that's a step. And I could actually save that as the query name and invoke that from other queries. Or I can make it a bit simpler. So instead of taking in all these function parameters there, I just want to make it take in a single query as text. And I'll turn that into a function. Instead of having the hard-coded Microsoft, I will pass in the query parameter. Okay. Let me zoom back out. And let me zoom out. Stuck. There we go. And now I have a function. I will call this Bing search. And let's see how we call that from another query. So I'll apply and save that. Now it's saved as a function. I will do another query here from another source, blank query, and I'll create a list of data. So I'll say Microsoft and then Power Query equals, yes, otherwise it's literal. Thank you. Okay, so now I have a list. I'll turn that into a table. I will go to insert custom column. And what I want to do is call my Bing search function and pass in column 1 as an argument. Now it says a table. And now I can expand, say, all the titles and IDs for each of those. So basically when I do that expand, it's going to dynamically invoke for that argument, the Microsoft argument, pass that into the function, and then return all the results in a table. And I can apply and close. That's going to refresh and actually show me all the different search results that come back. So that was showing how I can save one query and then use the data from one query to power or call functions that was defined by another query. Okay, so I think we're actually out of time. Let me just go quickly back. We'll show tips and tricks, and then we can stay around for some extra questions too. One quick thing I want to show, and we'll be making this available soon. While we don't have syntax highlighting in the editor yet, we do have, we use a program called Notepad++ and our own custom language markup here that actually gives us some form of syntax highlighting, and we can share that out afterwards. It makes it a bit easier when you're writing M from scratch. So we'll share that out after the talk. And let's go back quickly to the deck to cover one more slide, some quick tips and tricks, and then we'll go to answer some questions. So we mentioned this a lot of times. Leveraging the UI is usually the easiest way to work with them. So you'll generate your steps, you'll then tweak with the code. It's easier to do the formatting, And there's some things that are done automatically in the UI, like if you connect to a CSV file, the auto detection of the delimiter and the generation of steps. Those are a bit tedious to write by hand. It's a lot easier if our UI infers them for you. Using library functions. So usually when I'm writing anything in M, I'll have the formula spec up that shows me all the existing library functions. You can also use the pound shared to see all of the different functions that are exposed within the M language. And then troubleshooting. This is more of an advanced case, but if your queries have errors, you can use try and catch. You're not exactly sure why. It will show the errors. There's a function that lets you select and remove rows with errors. And also, if you need to disable query folding, there's a nice function called table.buffer that basically tells the M engine to say, okay, fold up to this point, then anything after table.buffer just do in memory. Quick resources, we have the link to the Power Query add-in, and then the language reference and library reference spec. So the language reference spec is about the structure and syntax of PEM itself. And the library reference is all the different functions.
I always get those mixed up.
Yeah.
Perfect.
And then finally, we'll end with some Q&A. It looks like we have a lot of questions, actually.
Yeah, so we'll try to jump through a couple of these. So first one I'm seeing is any limit to the data size. So there's no limit within Power Query. I mean, if you're doing some any in-memory processing, we're going to have limits based on resources on your machine. But there is a limit on the Excel sheet, which is just over 1 million rows now, I believe. So you'll notice in Power Query there's an option to load to the sheet or to the model. But Power Query itself doesn't impose any limits, row limits on data like that.
Yeah, and so this is another case where Power Pivot, like the difference between Power Pivot and Power Query, if you were connecting to a relational source that could, basically we can fold to and do aggregations and things like that, the Power Query is a great way to do those aggregations. If you don't care about the raw data, you just want the aggregated results. If you're working with a text file, like I've seen users trying to load, I don't know, a 6 gig XML file or a 6 gig CSV file, in that case, Power Query is going to try to do all the aggregation in memory, and it's not as efficient as loading it to the Power Pivot data model, which is kind of built for those types of optimizations, working with really large data sets. So that's one of those other cases where you want to first load into Power Pivot and do the aggregations there instead.
Great. So another question about writing our own functions. Can we supply some help text like the one showing for the library functions? That's a great question.
Today you can't. That's actually one of the first bugs I logged when I first joined the Power Query team, that we should do that. So Power Query has this concept of meta tags you'll see in the spec. I'm hoping that eventually we can leverage those meta tags to actually display function help text like the built-in library functions do today.
Yeah, right now the best way to probably work around that would just be to use the description in the query, because that does flow through when you share it and when a user consumes it. So that can give you some information. The other thing is making sure that your functions have type parameters on them, because that again will populate that invoke builder. But as far as having something show up in that default place that our library functions do, we don't have something like that today, but that's a good request. Okay, so next question. This is a good one. When you load your Power Query to Power Pivot data model, when you refresh the model, will it refresh Power Query? And if I publish it to my Power BI site, assuming the gateways are configured, will Power Query be refreshed as well?
So for the first part, yes. When you refresh, so all the queries you create with Power Query are refreshable. So you load the data to your data model. When you refresh the workbook, it's going to refresh those Power Query queries as well.
Through Power Pivot or through Excel or through Power Query itself, that connection will be refreshed.
So Power Query refresh through BI sites currently isn't supported, but a limited form of it should be showing up very soon, any day now. It should be appearing within the BI sites. And we're working over the next few months, we're going to be rolling out more data source support for Power Query support for BI sites. Yeah. So there's sort of a gap in our refresh story right now for Power BI, but we're working hard to close that.
Yeah, actively working on it. Great. So let's see. Question about Power Query getting rolled into Excel.
Yeah, you can see in the fullness of time, just like Power Pivot and I guess Power View was never really a standalone add-in, but just like Power Pivot used to be a standalone add-in and now it's bundled into Excel, you can sort of imagine that the same thing will happen for Power Query in the future. I can definitely see a tighter and tighter integration going forward.
Yeah, and similar question to jump over to a question about accessing data from analysis services. So, tighter integration. We're also working to, bridge any gaps that there are today, including data source connection and that sort of thing. So, analysis services is something that's commonly requested and is also on our roadmap as well.
Yeah, AS connectivity is probably our top requested feature, and it's something that should be going in fairly soon.
So a question about how to update one column in a table based on values in another column in the same table. So as you saw when Matt inserted his custom column, he can reference the associated row and invoke a function over it. So you can do similar things if you try, for example, duplicating the column and inserting an function or inserting a custom column. And you can actually do things based on the value in that row as well.
Yeah, if I go back to that last demo that I did where I was calling a function, doing an invoke, what it actually looks like is this. So I created my table, so I basically have my source data, my source table of data, and I'm using that each function that I talked about before. So for each row in my table, call the Bing search function that I created and pass in my column 1 value from that table.
Yeah, so that's how you reference values in other columns.
Yeah.
So let's see, any chance of getting generic OADB or ODBC support? Great question. Similar answer to what we said with analysis services. It's something that not only is a known gap today, is also a commonly requested feature. So it's something we're looking at throughout the Power Query roadmap.
Yeah, so in the fullness of time, you can imagine Power Query having every single data source that Excel and Power Pivot can currently connect to and more. And so we are basically balancing delivering new UI functionality and new functions versus new data source connectivity and stuff. I'd say that our top 2 requested features are, or top 2 requested data sources are analysis services and then generic OADB, ODBC connectors.
Yeah.
So
We hear you.
Yes, we definitely hear you.
So quick question on Power Query being on on-prem SharePoint. So Power BI itself is right now focused on SharePoint Online. I know that that's something that is also requested often and is being looked at as well.
So Power Query itself is standalone. It runs without a Power BI license, so you can get it within Excel. Refresh for, so if this is around refresh for Excel on-prem, for SharePoint on-prem is definitely something that's been requested. Yeah, something that I can imagine showing up in the future.
Okay, so question about finding workbooks that contain M code or search M globally. So right now, you can see that everything that we were defining and referencing is all within one workbook, and that's sort of the program has to stay within a workbook right now and reference it itself. You can use that sort of pound shared. You can use a way to look at what's in your workbook. Pound shared might not work with that now that I think about it, but you can use your Power Query workbook queries view. But as far as viewing other workbooks, that's not something that's currently supported today. I'm going to guess what Matt is about to show.
I thought I could show, but it ended up not. I thought I had shared some other functions.
Yeah, so instead of staying within one workbook, one of the things you can leverage with the Power BI license is the sharing functionality. So you can choose to share with your organization, but you can also choose to just share with yourself. And so that's one way to kind of keep track of your queries and have them easily accessible. So we can see if Matt has shared something. And so this is...
I haven't shared a function. But
yeah, he has one. There we go.
But yeah, so you can do sharing. Sharing Power Query functions is a bit limited right now. You can only really share a query if it doesn't connect to data sources. So I had an example where I was sharing like a date generation function that I blogged about, and I shared that within Microsoft so that people can consume it. And so that's really what the sharing functionality that Power BI gives you was meant to address.
Yeah, to share your full queries and that sort of thing. As Matt mentioned really quickly, sharing of functions is a sort of a more advanced scenario that's not fully featured yet that we're working on. But if you create a query that results in a table like this one, you can easily share it with yourself or with your organization to access it from another machine or from another workbook. So let's see, some coming in. Is Excel, or is the add-in available for Excel 2010?
Yes, it is.
Let's see. Can it be used? Can Power Query be used from a tabular model instead of from Excel?
Not yet. That's one thing that we're working in. Right now, Power Query Experience is specifically for Excel, but we are also looking at making Power Query available from Visual Studio when you're building tabular models.
Yeah, so that looks like the set of questions I got. Feel free to retype yours if I missed it.
Thank you. I think you covered all the questions in the list.
Great. They came kind of fast at some point, so my apologies if we missed any.
Thank you for doing that great presentation. Just mention to attendees the video of this webinar, the recording of this webinar will be available in our YouTube channel, which you can access online. If you don't have the address will be emailed to you.
Great.
Okay, cool.
Thank you, everybody, for attending.
Thank you for all attendees, and thank to Matt and Theresa for doing that great presentation.
Thank you.
Thanks.